Hello, how are you? Okay, so today we are talking about intersection event and multiplication rule. Alright, so first of all, intersection event. Probably you saw before algebra, maybe pre-algebra. So if you A, B is event in defined event, alright, in the sample space. So collect the all outcome and the common A and B. Looks like that, right? So we common this area. Intersection area, right? I think you know it, right? Alright, so denote A and B or this symbol. So just read A and B, or intersection A and B, or intersection A and B, or just A and B, or A B cup down maybe, or this way. Anyway, so read A and B or A cup down B, or write down this symbol using. Okay. How about multiplication rule? Multiplication rule. So first of all, joint probability. So probability of intersection two event called joint probability. So not only one, two event intersection, two event called joint probability. So A and B denote this way, right? This is more common use. Okay, multiplication rule. So probability intersection two event, obtain multiply margin probability, event conditional probability, second event. So first one, marginal probability times this conditional probability, two things. Okay, show that. So probability if it intersect two event A and B, right? Which means like here A and B, A times B given A. Okay, so here like for example, in the top here, same thing like A and B. So A, right, and the B, what kind of B? In A, which means here. So this one intersection over this is intersection. Okay, so all A and the B in A, so intersection this area. Okay. All right, next one, so example. So given the table, employee, company, gender, and college degree. Okay, so male, female, like gender, 27, 13. Each college graduate 11, and not graduate 29. Okay, that number total 40. Okay, the question. So one of employees selected random membership or employee managing committee. So probability employee female and graduate, college graduate, like female and right graduate. This probability they're looking for. Okay, so we have two ways. First of all, using intersection joint probability. So here, we're trying to using multiplication rule first. Okay, so this means P, the probability female multiply graduate in female. Okay, given female. Okay, so for the female means 13 or 40, and in female, right? In college student here 13 and 4 out of 13, 4 out of 13 multiplication like 10%, 0.1. All right, got it. Okay, next one. So PAIF female 13 of out of 40, right? And graduate the female, so graduate 4 out of 13. Alright, so 1% randomly employ female graduate. Or we can make the two female and graduate the total 40, and the female group and graduate group and common 4, right? You can just cross that common here out of 40, like 40. So not using the multiplication rule, just calculation. Simply we can counting 4 out of 40, right? 4 out of 40. What's easier? But later probably you should understand this part. Alright, using same table, if you want you do better. Can you make tree diagram? Tree diagram. This is much easier to understand. Look at, right? So first of all, male, female. Here 27, 13, 27, 13. And in first of all, male 7 graduate, 20 is not. So 7 graduate, 20 is not, right? And female 4 graduate, 9 is not. 4 and 9. Okay, this one 27 of, because man is 27. This out of 13, because female 13, right? So our question, female and graduate, female and graduate, right? So this number multiplication and this number come out and this number. Okay, so compute 3 other joint group 2. Male graduate, male not graduate, non-graduate, female non-graduate, this way. Okay, so multiplication, so on, so on. Okay, so you will get used to this way. Okay, all right. So example, 20 CD, 20, sorry, unbox 20 DVD, 4 is defective. Okay, so 4 out of 20 is defective, right? So 2 DVD select randomly, right? Not replacement. And what's the probability both defective? You can choose a 2 CD, like CD, right? So defective D1 like D2, and like a probability. The kind of question, all right? So we're trying to make tree diagram. So good and bad, right? So like here, we say the good, first one good, right? First one defective. So we said the 4 is defective. 4 is defective, 16 is good. 4 is defective, 16 is good, 4 is defective. Alright. G2, D2. Good, bad. Also here, 4. So 16. Alright. So 19. And 4 is good. So 19, 4 is bad, less than 1 is good, right? Also here, come out 4, take it out from the 19 here. 4 is good because already 1 is bad, so only need 3. 1 is bad, right? So 4. So here, this number, we are looking for both of the defective. The first D, right? Defective D and D2 given D1 right here. So we have 4 out of 20, and we choose one more because they're looking for only 2 DVD, right? 1 only selected, we only 1 will be defective, right? So this way. Okay, so try to understand tree diagram or this joint probability. Okay, so next one, this time conditional probability. So we know conditional probability like PAB. So this one, how you can get it? Do you remember P, A, and B? Right? So P, A, and this P, B, A. This way. Okay. So like 2 event, we do that, right? So this left here, just divide the PA. Okay, in this case. So should we match this one? Be match here. Okay. One more time. This means like A, P, A, and B, and P, B, P, A, B. That way. Okay. This conditional probability. So if you understand joint probability, conditional probability, same idea. Okay, of course denominator never 0. So conditional probability problem. So probability randomly select the student, college senior about 20%, 0.2. Randomly select about 20%, and the joint probability student, computer science major and senior. Okay, like A, B, A, something like that, right? Senior A maybe, and computer B, right? So B, A. So find the conditional probability. Student select random computer science major like given senior. Okay. So let's say maybe A is senior, B will be computer science. Okay. So here they said A, the computer science, B, and given senior like this way. Okay. So we've given information PA, which means senior will be 20%, and here 3% for when you together A and B. This A and B is given, right? So we knew it this way, right? So here PA and PAB, because AB is given because there is an and. Alright, by calculation. So conclusion. So condition 50% student random select. Random is computer science major given how she is a senior. Okay. Alright. So multiplication independent event. Total different, like die coin, right? Total different. So previous multiplication rule based on assumption two event dependent, right? Before dependent is independent is different, right? So if it independent, they don't care. What's the probability? Separately, A doesn't matter. Like toy head tail, die one even the odd number doesn't matter, right? Doesn't affect at all. Independent. So make separately. So AB conditional probability. So we're looking for joint probability, conditional probability, just independent event. So just simply multiplication, A and B. So like for example, coin head probability and even number, the die probability. This 1/2, this 1/2, right? So 1/4, something like that. Which means they don't care, right? Independent, separately, totally. The independent event, one more time. So office building has 2 alarm detector. Probability like 2% to 0.02. So any detector type failed to go off during it's bad. During the fire. So probability both fire detector fail to, right? The probability 0.2, okay? So fire alarms, fire detector probably separated, right? First floor, second floor, third floor, right? Different place. So should be what? Independent event. Okay, should be independent event. So let's say A is first detector, B is second detector. So joint probability should be independent, right? So joint probability separately multiplication, right? With this number. Okay. Alright. Other calculation probability 3 event. This time 3 event. So allergies penicillin is 2%, 20%. Supposed to ring admit to the 3 patient. Okay, so patient is supposed to be what? Totally 3 different person, right? Which is independent. So okay. So first question, 3. All 3 have allergy. Okay. And second question, at least one them not allergy. At least one. So maybe 3% not allergy, 3% not allergy, 2% not allergy, 1% not allergy. Okay, at least one. Okay, except 0. So at least one. Alright, so try to diagram, 3 patient totally different, right? 20%, 20%, 20%, 80%, 80%, 80%, or this way too. Okay, so first question. Yeah, total 3 independent, right? So event first, second, third. How can I do the multiplication each of them separately, like here? Even though the n, because independent, a, b, c separately, multiplication, here, there, right? How about following B question? 3 allergy, okay, we say Z. At least one patient. So at least 3, 2, 1, right? Except 0. Okay. So here to complement event. Because here's a 3. 3 patient allergies, not allergy, right? So 3 or 0, something like that. So we just separate and subtract this number. Okay, because complement, the relationship is the complementary. Okay, okay, right? We'll move on. Next one, study case. Maybe you reading books, just good information, right? This one also separate, independent. So just multiplication 10 times come out that anyway. All right, just move on. All right, I think almost last one. So joint probability, mutually exclusive, like a coin head tail, right? Get, didn't get, right? It, not it, right? So two mutual exclusive event, always zero probability. Alright, because always zero, one of them is zero, because they happen only one thing. So can you what's the how much probability head and tail? One of it is zero, right? One is the head, one half. If you come out head, never come out tail, right? Mutually exclusive. So AB mutually exclusive event multiplication will be zero, because this actually means PA, PB, right? They never happen together. Mutually exclusive never happen together, right? Complementary, simply tough. So one example, mutually exclusive event. So consider two event application. Field person obtain the car, right? So A prove, B reject. So mutually exclusive never happen together. So we find joint probability A and B, A and R. So A and R mutually exclusive. Either run application prove or reject. Only two choices, prove or reject. So we say that supposed to be probability will be 0, because one of them is supposed to be 0. Okay. Alright, so we talked about today intersection event and the multiplication rule. So you should know joint probability, right? And the condition too. And we should consider independent event. So we talking about independent, right? Independent event and mutual exclusive. Also, you should know it. Okay. All right. Thank you. Bye bye.